Dear children, so in the yesterday class we discussed about how to find the focal length of the lens. What do you mean by focal length of the lens? We discussed about convex lens and concave lens. Okay. Now we discuss about behavior of certain light rays when they are incident on the lens. That we'll discuss. So we know that we are having called two lenses, convex lens and concave lens. So this lens we are calling it as a convex lens, and here this lens we are calling it as a concave lens. So each and every time to draw becomes so difficult for us. So therefore we have a very convenient method, that is that. So if you draw like this, a straight line with this arrow mark like this, okay, and as usually this line having optic center, and here F1 and C1 and F2 and C2. This represents called convex lens. So each and every time instead of drawing convex lens, so this indicates that symbol of this one for convex lens, having symbol like this. In case of concave lens, so each and every time to draw like this, so we represent like this, okay, and here we show arrow like this, and remaining things will be similar. So we are having called like this, and here F1, C1 and F2, C2. So instead of now onwards, I will be drawing convex lens. Instead of drawing like this, I will draw arrow like this. Instead of concave lens, I will draw arrow like this. Okay, dear children, are you understanding? Okay. Now, so let us see that. So in this one, let us we study about called situation 1. Okay, situation 1. Let us see. Okay, no problem. Okay, situation 1. Situation 1. Here, light ray passing along principal axis. So let us here this situation 1 consideration here. How? For example, this is a convex lens and rotating like this, and here, so as already we know that we will be having like this. Okay, so this is of F1 and C1, and here F2 and C2. Now the light ray is passing along the principal axis. For example, there is a light ray is coming like this, and it is passing along this axis. The light ray is passing along this axis. In case of concave lens, so we have like this. Okay. So as usually this is of F1 and C1 and F2 and C2. If the light ray is passing along the principal axis, that is the first case. Whenever light ray passing along the principal axis, it passes as usually along the principal axis. It remains undeviated. So either recommend mark on same as usual, no change in that one. Right? Now let us go about for situation 2. Light ray passing through the optic center. Light ray passing through the optic center. Through the optic center. So look at here. This is a convex lens, and we know that this is the optic center, and this is of F1 and C1, and here F2 and C2. For example, light ray is passing through optic center like this, so it passes like this. Okay, it passes as like this. In case of concave lens, like this we are having. So as usually here. So children, remember very carefully that this is the optic center, and is here F1 and here C1 and here F2 and C2. So the light ray is passing through this optic center. It passes as like this. So now situation 3. Situation 3 we are discussing now. Light ray passing parallel to the principal axis. Light rays parallel to the principal axis. So this already we discussed in the yesterday class, that for example, so we have this convex lens, and here we are having this one. So we know that this is the optic center, and here it is F1 and C1, and here F2 and C2. In case of this, so this is about concave lens as usually, and here it is optic center, and here it is F1 and C1, and here F2 and C2. So here, so in this case, the light ray is coming parallel to the principal axis. Parallel to the principal axis. So we know that parallel to the principal axis means it passes through focus. Already we know this, we discussed. And here, in this case also, that the light ray is parallel to the principal axis. It appears to be going from away from the focus. It appears to be coming from focus. It okay, we extend back means it comes like this. It go like this. So light ray is parallel to the principal axis. It passes through focus. That you should remember very well that the light rays which are parallel to the principal axis, after refraction, they pass through focus. They pass through focus or appears to be coming from focus. That should remember very well. This point is very, very, very important. The punchline of this lesson. The light ray parallel to the principal axis. After refraction, it passes through focus. So look at it. In case of concave lens, it appears to be coming from focus. Remember, dear children, don't forget about this. Okay, this is about called situation 3 we are having. The next one we are having called situation 4. Situation 4 we are having. Same thing. Light rays coming from focus. Light rays coming through focus. Coming through focus. Very important. Here, look at here. This is called convex lens, having arrows like this, and here, okay, we know that this is optic center, here F1 and C1, here F2, and here we have got C2. In case of concave lens, so concave lens having like this, okay, right. So we know that this is called focus, okay, here F1 and C1, here F2 and C2 coming through focus, right? So look at here, in this case, okay, so the light ray is coming from focus. So if you take this point, means here you take this point, for example F2. So light rays are coming from focus like this. It is coming from focus here and here like this. And in case of like this, it is coming through focus. Okay. So it is coming from focus. So after refraction, they will emerge as a parallel to the principal axis. They will go here like this, parallel to the principal axis. That you should remember very well. So the light rays will go like this. This is very, very important. Okay, the light rays coming from focus, they will emerge as parallel. The light rays parallel to the principal axis will go through focus after refraction. This to be remembered very well. And here also like this. For example, light rays are coming towards focus. Here light rays are coming like this. It is coming towards. Okay, it is also coming towards focus. Right. Okay. So here, okay, it is coming towards focus. It is coming towards focus. Here, okay. So they will emerge parallel to the principal axis. They will emerge as what? Parallel to the principal axis. They will emerge parallel to the principal axis. So like this, we are having like this 4 situations are given. Remember that this is situation 3 and this is about situation. Okay. So they are very, very important. Situation 3 and situation 4. Okay. Okay, dear children. So now we discussed about 4 cases: situation 1, situation 2, situation 3, and situation 4. So for drawing the image formation by lenses, we can require any 2 situations and we can complete the image formation. Any 2 rays. All the time we need not to draw the 4 situations. Any 2 situations are enough to complete the image formation by the lenses. Are you understanding? Okay. Now let us see the first case, that when the object is at infinity. First case, when the object is at infinity. So already we discussed that in case of when the object is at infinity. So I'm talking about convex lens. So convex lens. So image formation by convex lens, the object is at infinity. So already we know that this is a convex lens. Okay, and here, as we know that, so we can keep like this, right? This is the optic center, right? This is called F1. To the F1 double of this, we have a generally center of curvature C1 and here of F2 and C2. Why? Because F1 C1 F2 C2 means every lens we have 2 foci and 2 center of curvatures. Object at infinity meaning that the object is situated somewhere beyond C2. It is situated somewhere beyond C2, very large. Maybe infinity means like sun or any very large distance. So whenever in physics infinity means, we can assume that the light rays are parallel to the principal axis. That should remember very well. So for example, here in case we are having this. So light rays are having called parallel to the principal axis. So look at here, parallel to the principal axis. So we can give like this. Okay. So here any 2 light rays are enough. So I am drawing here one light ray like this. One light ray. And here one more light ray. So this light ray, after refraction, they will pass through. These 2 light rays will meet at this point. Okay, right? So these two light rays are meeting at focus point, right? So when the object is at infinity, image is formed. Image is formed at focal point, or image formed at focus, and it is real, and it is point size. The size of the image is very point, focal point it is, and it is point sized, and it is point size. It's very important. Image is formed at focus point is the first important point, and second point is image size is how much? It is point size. This is the first case. Okay, now we will look at into the second case. Okay, second case means we will take down like this. When the object is beyond C2, beyond center of curvature. Just C means center of curvature. Okay, how that will be formed? Let us see. Look at. Okay, this is the convex lens, as we know that, and here, so we know that this is lens. Okay, so optic center, and here F1 and C1, and we are having called F2 and C2. Now object. So we kept object beyond C2. Here, for example, I am keeping the object like this, right? I am keeping the object like this. Okay. So I kept the object like this. So here I kept the object like this. This is the object called AB. So let us see how the image will be formed in this case, right? When we kept object is one, we can take any two light rays. So one light ray parallel to the principal axis. So we know that parallel to the principal axis will pass through focus. Okay, this is clearly understood. And another light ray passing through the center of curvature, passing through optic center. So they will meet here at this point, or okay. Here we can doing like this. So if extend like this means okay, and here. So these two light rays are meeting at this point. Now we draw a line like this. So we get here inverted image. Okay, A here and B. So remember very carefully. At this point, beyond C2, we kept object like this. Image is formed like this. It is inverted. Are you understanding clear? Okay. So any two light rays are enough to draw the image formation. I have taken two light rays. One light ray is traveling parallel to the principal axis, and one light ray passing through optic center. Alright. So draw a line like this. So now here we have to remember very well that image is formed between F and C. Remember here. When object is kept beyond C2, image is formed between F and C here. That is very important here. So we can write down that image is formed between F and C. It is real and inverted and also diminished. So very important. Diminished means decreasing size. What is that? Decreasing size. Initially it was this much, and afterwards it formed only small, very small. Okay, this is very important. When the object is beyond C, image is formed between F and C, and it is real, inverted, diminished. Right. Now in this case, let us study about the third concept. That here, third concept. Now we'll keep the object between C and F. Okay. Now let us discuss about another one called when the object is in between F and C. Or okay. Now let us see about this case. F and C. Now this is the convex lens. Okay, here same concept, right? This is optic center, right? And this is F1 and C1, and here also F2 and C2, right? Now I am giving the object here beyond. So when the object is in between F and C, look at here, F and C means I am giving the object like this. This is AB. So I will take like this, one parallel. Okay. Okay. So when the object is AB, so again we are taking here one light ray parallel to the principal axis. So we know that parallel to the principal axis means it passes through focus. Okay. It passes through focus point. Okay. And another light ray passing through optic center. So here we can do like this, or here we can do like this, or we can, next this is of C1, so we can do like this, right? By doing like this, just okay. So in this case, image is formed here. Look at here very carefully. Remember that here. This is called A dash, B dash. So image, this is of C1. So when we keep object between F and C, image is formed beyond C. That's very important. And it is enlarged, big in size, real, inverted and magnified. Image is formed beyond C. That's very, very important. Okay. So when object is in between F and C, image is formed. We can write down that image is formed beyond C. An image along the characteristics, it is real, inverted and also magnified and magnified. Are you getting points here? So far we discussed about three cases. Three cases we discussed. When the object is at infinity, when the object is beyond C, when the object is in between F and C we discussed. Okay? Right. So now the fourth case, when the object is at C means center of curvature. So we know that this is a focus, convex lens. Okay. So as usually we have to draw the ray diagram for this one also. So we know this is optic center, and here F1 and C1 and F2 and C2. So now we will keep the object at C, means I am keeping the object at C here. I am keeping the object at this point C. So I kept object at this point AB. So as usual I am taking this one light ray parallel to the principal axis, right? So in the parallel to the principal axis, it will pass through focus. Okay, it passes through focus like this, and one more light ray passing through optic center, right? So passing through optic center. So here they will meet at this point. Okay, just I am using here. So they will meet at this point. Okay, we can draw like this. So they will meet exactly at C1. So we can draw line like this. Just I'm trying to here show carefully very AB. So here image is formed exactly on this one. It forms like this. So AB object here we can call A dash and B dash. So very clearly we can show like this also. So it forms like this. Okay. So here, right. So maybe some small mistake. Okay. Look at here. When the object is at C, object is at C. Image is formed at where? Image also formed at C only. If it is same size also, you can if you refer dimensionally also means it will be of same size. So we can write down that when the object is at C, image is formed at C. How it is means real, inverted and same size. Same size means ఎక్కువ కాదు తక్కువ కాదు, same size అన్నట్టు, having same size. Are you understanding very clearly? Now, so in the case, that fifth case, when the object is at F. Right. Now, so as usually, so this we are having called convex lens. Okay. Here same thing. This is called optic center. So F1 and C1, and here F2. So object F means object is at the focus point. So here we can remember that object is like this. Object is at focus. Okay, this is called AB. So parallel beam of light rays. We know that parallel beam of light ray will pass through focus, and one more light ray passing through optic center. So now both rays are parallel to each other. That means they are not meeting at any point. That means image is formed at infinity. We can say that what? Image is formed at infinity. So an object is at the F means image is formed at infinity. That you should remember very well that. So we do not talk about its characteristics. If you talk about characteristics, means image will be very highly magnified, real, inverted, and it is very, very highly magnified. The last case we are having called that last case, when the object is in between F and C. That in between F and C, in between F and optic center. Okay. Sorry, F and optic center. So look at here the last case. Okay. So this is here we are having like this, and this is of convex lens, optic center. Here F1 and C1. And here F2 and C2. Okay, now, so we talk about this here. Okay, object is in between F and O, means we are keeping like this. Object I kept like this. Object I kept like this. They are having AB. This is called AB. So parallel beam of light ray like this. It passes through focus. Okay. So optic center means like this. We are having optic center is like this. So it is passing through like this. Okay. Pass through like this. Optic center. So if we extend these two light rays, back side means if we extend these light rays back. Okay, if we extend this back like this means. And also this line also if you extend means, so they will meet somewhere at this point. Okay, they will meet at somewhere at this point. So where image is formed on the same side of the lens, right? Image is formed on the same side of the lens. That is AB, A dash and B dash. A dash and B dash. So in this context, you remember that image is formed on same side, but not on that side, same side. So we can call it as image is formed virtual. That image we call it as the image is formed before the lens. This image will be called as image is virtual, erect, and magnified. Virtual. That we are calling. Okay, these are 6 characteristics you have to remember very well about that one. Okay, so these cases are very, very important in convex lenses. First case is very important when the object is at infinity, and second case when the object is beyond C2, beyond center of curvature, and third case when the object is at focus, and fourth case when the object is at C, and the fifth case when the object is at focus, image formed at infinity, and the last case where the object is in between optic center and focus point. Okay, thank you.